Hey there everybody, and thank you for joining me for today's lesson. Today we are going to keep talking about probability. So let's start with a warm-up where we talk about a bunch of those vocabulary words that we learned yesterday. So first of all, we have our I can statement. Our I can statement today is I can compute the probability of simple events. Okay, so first question here. Probabilities are what? They're ratios, right? Probabilities are ratios, so they can be expressed as fractions, decimals, or percents. And you see the little star beside fractions? That's just because that's the most common way we'll see them. Usually, we're going to be using fractions for these events. All right, events that have the same chance of occurring are called equally likely events. So like when you flip a coin, it's equally likely whether you get heads or you get tails. The set of all possible outcomes is called the sample space. So again, with flipping a coin, the sample space would be heads or tails. Those are the two possible outcomes. Let's go to question 4. Jenna rolled a die and got 7 2s. She concluded that the probability of rolling a 2 is 7 over 10. Which type of probability did Jenna compute? All right, so which one did she compute? It was based on an experiment. She actually rolled that die 10 times. So it's like she was doing an experiment, right? So that was experimental probability. Okie dokie. And now it says, is the following a proper probability model? Yes or no? And explain your answer. Okay, let's take a look at this. Here are the possible outcomes. We have red, blue, and green, and the different probabilities for each one of those. Now remember, there's a few rules with the probability models. First of all, the probabilities have to be between 0 and 1. And second, all of the probabilities that are listed have to add up to equal 1. So let's see if this fits the bill. First of all, are they all between 0 and 1? No. First of all, we've got a negative number here, so I'm going to go ahead and circle my no. We have a negative probability, so in other words, that is not between 0 and 1. Between 0 and 1. All right, what else? 1/4, that's between 0 and 1, good. What about 7/4? That is not between 0 and 1, so 7/4 is over 1. So in other words, it's not between 0 and 1. What about if we added all these together? Would they total up to be 1? Let's see, 1/4 minus 1/4 equals 0, plus 7/4, that equals like 7/4. It equals 1.75. That does not total to equal 1. So the third reason would be they do not add up to 1. So 3 good reasons this is not a proper probability model. Okay, there we go. Let's keep going. 6a, if an event is impossible, there's no way for it to happen, its probability is 0. All right, cool. What about if it's a certainty? What if it's definitely going to happen? If an event is a certainty, its probability is 1. Okay. The tally, number 7, the tally of how many times an event has occurred is called its what? And here's a nice little hint for you. Starts with free. That's going to be its frequency. So frequency is how many times an event has occurred. Okay, and number 8 says when we make a ratio of the number of times an event has occurred to the number of trials, we call this the relative frequency. Okay. Number 9, the theoretical probability does not require an experiment, but is simply based on all the possible outcomes. We take the number of ways the event can occur and we divide it by the total number of possible outcomes. Okay. And number 10, we can totally skip that one. This had to do with some calculator work that was on yesterday's that I had you skip, okay? And then number 11, think about the coin and dice experiments. Theoretical probabilities are what we expect to have happen. They're theoretical, that's what we expect. If we flip a coin heads or tails, we expect half the time it'll be heads and half the time it'll be tails. whereas experimental probabilities are what actually happen when we conduct a probability experiment. So if we flipped a coin 10 times, we would expect 5 heads and 5 tails. But the experimental probability would be whatever actually happened. It might be 6 heads and 4 tails, or it might be 8 heads and 2 tails. It could happen. It's not that likely, but you know, that's what an experimental probability is. That's what actually happens. Okay, now that was our kind of warm-up review of vocabulary. Let's go on to our new stuff. Okie dokie. A simple event is a single outcome from a probability experiment that is conducted one trial at a time. Guys, there's a lot of words in this. Just hang with me for 1 second and we'll start explaining exactly what all this means and how it's done, okay? So one trial at a time. Simple events are usually the results of probability experiments that are easy to describe and understand. For instance, rolling a die, flipping a coin, spinning a spinner, drawing a marble from a bag, picking an individual from a list, etc., etc. Okay. Simple events are usually calculated using theoretical probabilities. This means we need to know how many outcomes are possible and how many outcomes are in our desired event. Stick with me, we're going to keep talking about this. Okay, let's look at this. Let me get this out of the way. All right, this is starting with example 1. This is going to be a lot like what you're doing on your assignment for today. So let's read it. A set of 20 cards is numbered 1, 2, 3, all the way up to 20. So we have 4, 5, 6, we have all the way up to 20. Now suppose you pick a card at random without looking. Find the probability of each event and write it as a fraction in simplest form. And my cat is meowing at my door. If you hear something, that's what that is. Okay, so we have a set of 20 cards, and we need to know the probability of drawing a 2. And now my cat's attacking the door. Well, I'm just going to ignore that. Okay, the probability of drawing a 2 out of 20 cards. So what is the total number of outcomes that are possible? 20, right? Because there are 20 different cards. Okay, cool. Now, how many different ways can we draw a 2? There's just one card that's a 2. You only get one draw. It's not like we're trying to add up to 2. What's the probability that you take your one draw and you get a 2? There's only one way to do that, with the 2 card, right? So the probability of drawing a 2 is 1 out of 20. Now, what is the probability of drawing either a 2 or a 12? Well, it's still out of 20, right? There's still 20 cards total. But this time, we could draw a 2 or a 12. So there's 2 different ways to get this desired event, right? So 2 different ways to do it. We're going to make that top number a 2. 2 out of 20. Now you might notice that this fraction can be simplified, so we're going to go ahead and do that. Divide that top number by 2 and the bottom number by 2, and you get 1 out of 10. Okay? Let's try part C. What is the probability of drawing an even number? Well, the total number of cards hasn't changed. It's still 20. Now, how many out of those 20 cards are even? You've got 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20, right? That's 10 cards, so half of them are even. That's what we would expect, right? So your probability is 10 out of 20. Now, can we simplify that? Yeah, let's simplify it to 1/2. Okie doke. Let's go to part D. Now this time it says, what's the probability of not 2 or 12? Okay, well, what's our total? It's still 20, right? What's the probability of anything except 2 or 12? Well, that's just, you would have the total number of 20, but you can't do this one or you can't do that one. So there's 18 ways left that you could draw. So it would be 18 out of 20. So basically, if you count up all the numbers that are not 2 and not 12, you get 18. So can this be simplified? Yep, let's divide them both by 2 and you're going to get 9 out of 10. And one more in this question set. What is the probability that you get a factor of 20? Okay, what are the factors of 20? Those are those numbers that 20 can be evenly divided by, or that multiply into 20. So you've got 1, 2, 3 isn't a factor, but 4 is. 5 goes evenly into 20. 6, 7, 8, 9, 10. and then just 20 right there. Okay, so it looks like there's 1, 2, 3, 4, 5, 6 of these numbers are factors of 20. So my bottom number is still going to be 20 because there's still 20 cards. And it looks like 6 of the cards are factors of 20. So 6 will be my top number. And now let's just simplify it. We'll divide both of these by 2 and we'll get 3 over 10, 3/10. Okay, let's look at example 2. This time we're going to be talking about this spinner over here. It says use the spinner below to find the probability of each event. Write as a fraction in simplest form. Okay, so here this P parentheses S, it means what's the probability of spinning an S? Well, first of all, let's figure out the total number of all the possible outcomes. In other words, the sample space. How many different letters are on here? 1, 2, 3, 4, 5, 6, 7, 8. So our bottom number is going to be an 8. Now, how many ways can we spin an S? Well, there's this S right here. Are there any other S's? No, that was the only S. So there's just one way to spin an S, and that'll be your top number. So your probability is 1 out of 8. Okay, let's look at part B. What's the probability of spinning a vowel? Well, our sample space is still the same. It's an 8. But how many vowels do we have? Let's find out. O is a vowel. P, Q, R, well, actually, O is the only vowel, so I guess it'll just be 1 out of 8 again. What about the probability of spinning a consonant? Sample space is still 8. How many consonants are on there? Well, if we had one vowel, the other 7 are probably consonants, right? So we're going to do 7 out of 8. Now, D is kind of fun. What's the probability of spinning a letter that's made with curves? Let's figure this out. Well, we're still going out of 8. How many of these letters have curves? No, no, no. Yes, 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 yes. So there were 5 yeses. So the probability of spinning a letter made with curves is 5 out of 8. All right, guys, we're almost done. Stick with me just another second. We're going to make a little probability model from this situation. Let's read. A marble is to be drawn from a bag containing 8 blue, 5 purple, 11 orange, and 6 red marbles. Now we're going to make a probability model for this situation. It says to write all fractions in non-reduced and reduced form. Okay, we can do that. Okay, so what are all the possible outcomes? Blue, purple, orange, and red. I'm sorry, I'm laughing at my cat. If you see me giggling, that's what's going on. He's still meowing. So blue, purple, orange, and red. Okay, so those are the 4 possible outcomes. What about the frequency? Well, you know what? We can just copy those down from here. If there are 8 blue, then the frequency is 8. If there are 5 purple, the frequency of that is 5, 11 orange, and 6 red. Okay, done with that. Now what about the probability or the relative frequency? Well, to know the probability, we need to know the sample space. We need to know how many different marbles there are. And we're going to put that number on the bottom. So 8 plus 5 is 13, plus 11 is 24, plus 6 is 30. So 8 plus 5 plus 11 plus 6 is 30. So 30 is going to be the denominator for all 4 of these. At least until we simplify. Then it might change, right? But we're going to start out with 30 on bottom. So the probability of drawing a blue is going to be this number over 30. So you're just going to take that 8 and put it on top. For the purple, you're going to take that 5 and put it on top. The chances of drawing a purple are 5 out of 30 because there's 5 purple marbles out of a total of 30 marbles. So your chances are 5 over 30. What about for orange? You've got 11 orange marbles, so we put the 11 there. And for red, we've got 6, so we'll put the 6 right there. Now let's go ahead and simplify all of our fractions. So 8 over 30, both of those are divisible by 2, so it's going to become 4 over 15. 5 out of 30, both of those are divisible by 5. Let's go 1 out of 6. 11 over 30, can't simplify that one. And 6 over 30, both of those are divisible by 6. So 6 divided by 6 is 1, 30 divided by 6 is 5. All right, so this part is complete, and now we're just going to complete this part. So find the probability of each event. Write as a fraction in simplest form. So probability of blue, well, we've got it right here, 4/15. Awesome. What about the probability of red? Red, 1/5. Now they change it up a little bit. What's the probability of blue or red? So in this case, you're going to take the blue and the red, and you're going to add them together. Now it's kind of hard to add these two numbers together, right? But over here, before we simplified, they both have the same denominator. So we already have common denominators here. So we're going to do 8/30 plus 6/30, because that's the probability of the blue plus the probability of the red. So 8 plus 6/30, and that's going to equal 14/30. Now we do need to simplify. Let's just divide by 2, and we'll get 7/15. All right, awesome. What about the probability of not orange and not red? Okay, so we want to get rid of that one, get rid of that one. All we're left with is blue and purple. So let's add these guys together. Again, not so convenient to add these numbers. Let's add these instead. We'll go 8/30 plus 5/30 equals 13/30. And can we simplify that? No, that's fully simplified already. So we are done with that. And that is all the notes we have for you for today. You're ready to start your assignment. Your assignment looks like this. This is a very similar problem to the one that we just did. Just figure out the probabilities for each of the marble draws. Then we've got some spinners for you. And then over here, we've got some card draws. So all very similar to the notes I just gave you. And I'm going to let you skip 22 through 30. Okay, thanks so much for watching, and let me know if you have any questions. Bye.